Fellow participants, ladies and gentlemen, I would like to apologize for the delay of 2 minutes. Sorry. We will now resume our sessions on genetic and breeding again. I would like to invite our good Dr. Ong to continue his role as the moderator for this session. Please, Dr. Ong.
Yeah, thank you very much, Ms. NC. Welcome back to our sessions. So our next speaker will be Dr. Annamalai Maavel from India. Allow me to read his CV. He's currently based in Institute of Forest Genetics and Tree Breeding in Tamil Nadu, India. His position is scientist. He's been involved in tree improvement program of Acacia auricaliformis and few other fast-growing species. He also developed clones for enhancing productivity in farm industry, also associated with domestication of casuarina clones in southern India. Without further ado, I would like to invite Dr. Malaval to present his presentation.
Am I audible, sir?
Yes.
Respected moderator, delegates, and scientific fraternity across the globe, ladies and gentlemen, good afternoon to one and all person here. First of all, I would like to thank the organizer to providing this opportunity to present the topic on evaluation of provenance of Acacia mangium for survival, early growth in Karnataka and southern India in this generous gathering. I have divided my presentation into 5 different subtopics. First, we will discuss about the introduction. In the introduction, we will see about the background of the demand and supply in India, as well as the importance of Acacia mangium in India. And subsequently, we will discuss about the international provenance trial program in different countries, and the materials and methods, result and conclusions. In introductions, India, one of the most important wood consuming country. The demand of the wood and wood-based product is increasing, particularly in the construction, furniture, wood panel, and paper industries. India alone having more than 800 paper mills. It is the wood requirement is expected to cross more than 40 million by 2030, with the annual growth percentage of 7 to 8%. Other wood industries like panel product, ply, particle boards also require 8 million cubic meter of wood, against which we are producing only 3.4 million cubic meter wood. The demand of the furniture industry also rising 12 to 15% annually. Our demand is 153 million meter cube wood, against which we are producing 88.7 million meter cube. We are still in the wood deficient country. We are importing the wood for our domestic needs and construction needs. In addition to the deficiencies, the higher population explosion, increasing income, urbanization, adopting Western culture, growth of the real industry, particularly in the modular kitchen, designing the wall, floor, wall and ceiling by the wood, and growth in the railway and defense sector, the government schemes like Housing for All 2020 and development of smart city, tourism, and consumption for the papers in the e-marketing also put additional pressures for the demand of the wood in India. Our national forest policy also emphasizes the wood-based industry. They have to depend on the raw material from the tree outside the forest. The Indian forest has a very low productivity when compared to the world average. There is a significant rise in the wood and wood for the industrial demand in 2050. So to meet this challenging situation, the short rotation forestry is only the viable solution to meet the emerging wood demand in the future. The growing of the trees in the farm forestry, in the block plantation, agroforestry is help us to meet the emerging demand in the country. It will also support the livelihood of the millions of the rural populations. Out of our wood productions, the maximum amount of the wood produced from the tree outside the forest, followed by import of the wood. So among the different species, acacia is one of the most important fast-growing leguminous tree species native to Australia, Papua New Guinea. It is a potential agroforestry trees grown in the farmland and forest land. In Kerala, they are This is prevalent for growing the pepper in the acacia mangium trees. In India, it is introduced in 1980 for the paper and pulp productions. In India, it is particularly cultivated in Kerala, Karnataka, Maharashtra, Odisha. More than 50,000 million hectares were cultivated until up to 2016. After 2016, some social and political issues, the area under the cultivation of Acacia mangium was reduced due to the various reasons. Still, the paper mills and Forest Development Corporation and Forest Department are also growing the Acacia mangium. So Acacia mangium has a very fast-growing tree species. It provides higher yield. The wood is used for furniture, paper, pulp, particle board, carving industries. It's a short rotation tree species. The pulp industries, you can harvest the trees within 4 to 5 years. The trees is very well suited for the acidic soil. The pH less than 4.5 also it can come. It will enrich the soil with adding the nutrients and fixing the soil nitrogens for improving the degraded soil. So considering the importance of this Acacia mangium, the Acacia breeding program at the Institute of Phytogenetics and Tree Breeding was implemented by my previous speaker, Dr. Magesh Hegde, was instrumental for the improvement of the tree breeding in Acacia mangium, in particular in the southern part of the country. He has run the systemized program in the country by receiving the seed lots. He already explained about this improvement program in India about Acacia mangium. He received the breeding population of 80 families from the CSIRO Australia, and subsequent thinning, we were established the first generation orchard. From the first generation orchard, we have also supplied the seeds to the stakeholder for improving the productivity. In subsequent thinning, we are also established the second generation orchards. From the second generation orchard up to 2006, we have supplied the seed to the various forest department and paper industries for meeting this, establishing the plantations. So international provincial program was initiated by the Australian Tree Seed Center by CSIRO Australia. Due to the provinces already having the acacia growing conditions as highly affected by the Ganoderma and so. So in order to enhance genetic base of this Acacia mangium breeding populations, the fresh infusion need to be included in the breeding populations. So CSIRO Australia has collected the new provenances from the original center of the origin and shared to the different country. India also is one of the partner for implementing the international provincial program by CSIRO Australia. So with the seed lot received from the CSIRO Australia, we have conducted the studies to assess the variation in tree morphometric and the seedling characters of Acacia mangium, and to evaluate the new set of provenances for Acacia mangium for the survival, growth, and seeds. These are the seed lots collected by the totally 16 seed lots we have received from the CSIRO Australia, of which 14 has the very good germinations. This 14 seed lot will be used for the studies. The seeds were collected from the different seedling seed orchard, seed production area, CSO, and natural populations. We have also collected the seeds from our Nilambur seedling seed orchards to compare the performance. These are the geographical locations of the seeds collected by the CSIRO. The seeds were raised we have raised the nursery in the model nursery of Institute of Phytogenetics and Tree Breeding in Tamil Nadu. About 600 seeds provenances, 600 seeds per provenance were sown in the polybag containing vermicompost, soil, and organic manure. We have observed the variations, we have recorded the variations by the seed characters such as seed area, seed length, seed perimeter, 100 seed weight. In seedling characters such as percentage of germination, seedling length, basal diameter, number of loads. These are the characters we have observed in the seeds and seedling traits. This is the establishing the nursery in the for raising the international provenance trial. So we have raised the international provenance trials in 2 different locations, one in Ramnagar, Karnataka, Uttar Karnataka. This area receives more than 2,800 mm of rainfall, with the temperature varies from 16 to 70 degrees Celsius. We are out with the row column designs. 15 provenances were planted in 4 replication at a 3 into 3 meter spacing. Each plots, we have maintained the 16 tree plots. Each provenance we have maintained 16 tree plots. This is the present status of the international provenance trial at Uttar Karnataka. We have raised the second trial at Sakleshpur, Hassan district in Karnataka. Here also the temperatures varies from 17 to 35 degrees Celsius. We adapted the row column designs, and 15 provenances were planted in 4 replication at 3 into 3 meter spacing, and 16 tree plots were maintained. So this is the present status of the Acacia Mangium International Provincial Cousins. So we recorded the basal diameter, breast height, total height, number of branches, stem tightness, and branch diameter 2 years after planting. It's the yearly observations. So regarding the mean variation between the seed morphometric character, the seed area is varied from 0.08 to 0.18. Seed length is varied from ranged from 0.40 to 0.61 centimeter. Seed breadth is ranged from 0.26 to 0.38 centimeter. Perimeter of the seeds is ranged from 1.6 to 1.70 centimeter. Among the different seed lots, the Papua New Guinea natural province had the higher seed morphometric characters, whereas the higher germination percentage was recorded in the Queensland provinces. Regarding the seedling parameters, the percentage of germination is varied from 33.83 to 86.17. The average seedling height is ranged from 16.44 to 29.09. The basal diameter is ranged from 1.84 to 2.50 centimeter. The number of nodes also ranged from 3.40 to 5. So among the different provinces, the IFGTV SSO seedlings have the higher germination percentage, which is followed by the Papua New Guinea natural provinces. The average seedling height also higher height was recorded in Papua New Guinea natural provinces, and higher basal diameter also higher in Papua New Guinea. If the correlations, the seed area is positively correlated with the seed length, seed breadth, seed perimeter. The seed length is positively correlated with seed breadth and perimeter. Seed breadth is correlated with the seed perimeter. The survival percentage at the age of 24 months after planting in the 2 locations. The highest survival percentage was recorded in SSO originated from the SSO seed lots from IFGTP, 90.63%, which is followed by Papua New Guinea and Queensland provinces. Philippines seed lots collected from the Philippine SSO also had the higher percentage of survival in Uttar Kannada. Whereas in the Hassan and the other location, the higher percentage of survival was recorded in the Queensland provinces, which is followed by the IUFRO provinces. So the basal diameter of among the different provinces in the first trial, the Uttar Kannada is varied from 11.6 to 15.4. The average GBH is varied from 21.28 to 15.84. The average total height is varied from 3.9 meter to 3.25 meter to 3.92 meter. So number of branches also varied from 9.90 to 14.5. The average stem straightness is varied from 3.3 to 4.5. The average branch diameter is varied from 3.6 to 4.5. So among the different provenances, the higher height was recorded in the IUFRO SSO originated seedling, which is followed by the Vietnam CSO. The second trial also similar trends was observed. It is varied from the basal diameter varies from 10.46 to 12.51, and the average GBH is ranged from 17.48 to 21.98 centimeter. Average height is ranged from 3.9 to 5.20 centimeter. The number of branches is ranged from 10.85 to 13.85. The stem tightness also similar trends, 4.0 to 4.73. This is the graphical recommendations representation of the growth parameters, the height and the GBH in 2 different locations. In conclusion, there is a wide variations which occur on the seed morphometric characters. The highest germination percentage was recorded in the seedling seed orchard, first generation seedling seed orchard established by IUFRO, followed by the Papua New Guinea natural provinces. The maximum plant survival rate was recorded in the CSO seed lots received from the CSO Vietnam, which is followed by the IUFRO SSOs. There is no statistical difference, significantly differences growth on the growth parameter in the early age. The early observation revealed that the seed lots received from the Vietnam CSO and IUFRO first generation seed orchard showed the commendable growth among the provinces in International Province Trial 1 and 2. So further studies need to be carried at the age of 4 and 5 years after planting for the growth stem from proper general for funding support to establishing these international province trials. I place the record of heartfelt thanks to Australian Tree Seed Center, CSRO Australia, for sharing the new set of provenances to widen the genetic base of this Acacia mangium and in India. I acknowledge the effort of Dr. Mageshwar Hegde, the Acacia Tree Improvement Breeder, for the guidance and providing the guidance and support, and also express the Director Institute of Phylogenetics and Tree Breeding for commendable support. Thank you very much for the.
Thank you very much, Dr. Well, any question from the participant to ask question regarding provenance performance of the fused Acacia mangium species? If not, the questions, just want to ask, any correlation between, because your side, mostly the rainfall is less than 2000 ml.
Yes, sir.
So is there any correlation from the best performance from Papua New Guinea is related to the similar rainfall distribution from the natural area?
Yes, sir. One location in Dondelly, it is receiving more than 2,800 mm. It is similar situation. The provinces are performing. The Papua New Guinea provinces is performing in the third place, sir. First is Vietnam, followed by Papua New Guinea, then IUGTB seed lot in the particular location, sir. Whereas other lots, the Papua New Guinea provinces comes for the second places, sir.
Thank you for mentions. Thank you for the presentation. Any other questions from the participants or from the floor? No, and then thank you very much. If any questions, please post it. Probably the presenter will be able to respond in the chat group or the Q&A group. Thank you very much, Dr. Marvel.
Thank you.
We move to the second presenter. It's actually from Dr. Julian Marano Chan. He's currently principal scientist at the Institute of Commercial Forestry Research. He will present on the genetic variation in frost hardiness, rust resistant, and growth in a cold-tolerant population of Acacia mangiae. Allow me to read his CV or biodata. His experience in forest maturation, tree improvement, and wood quality of wide range of forest species in Mexico, Australia, and South Africa. He is currently, as I mentioned, group leader for the tree improvement at the Institute of Commercial Forestry Research. Main responsibility is actually both for Acacia mangiae and also eucalyptus is actually doing the breeding program. He had PhD in forestry science in 2007 from University of Canterbury, New Zealand, Bachelor of Forestry in 1993 from Mexico. So without further ado, I pass this floor to Julian, please. Julian, can you hear?
Yes, I'm busy sharing my screen. Please tell me if you can see.
Yes, we can see it.
Okay. All right. All right. Let me just minimize this thing here. Okay, can you all hear me and see my screen, please?
Yes, both again. Yes, please.
Okay, thank you. All right, thank you very much for your words and for your introduction. As you mentioned, I'm based in South Africa at the Institute for Commercial Forestry Research. I'd like to acknowledge my co-author, Professor Fikret Isaac from North Carolina State University in the US. Fikret is a genetic quantitativist, and he's an expert on genetic analysis of disease data. Okay, so this study has been recently published in Forest Science, as you can see there. Right. Okay, let's start. So black wattle, Acacia meonsi, is naturally distributed in southeastern Australia, and it's an economically important species in South Africa with about 110,000 hectares planted, of which about 30% are under risk of frost damage. Okay, the bulk of the plantation tree resource is the local land races, which were introduced to the country in the 1800s, and these are not frost tolerant. The current planting stock cannot tolerate temperatures below -3 or -4 degrees Celsius. An additional challenge in frost areas, on frost affected areas, is the emergency of the wattle rust disease caused by the fungus or Eurymaclidium acacia. So there is an urgent need to develop seed sources and clones, both tolerant to frost and resistant to rust, for deployment in frost affected areas in the country. Currently, there is a lack of knowledge about the level of genetic variation for frost tolerance in the species. All the previous studies have focused mainly on provenance variation. It's also important to mention there is a lack of information on the genetic relationships between frost tolerance, wattle rust disease, and other economically important traits for this species. So the overall objective of the study was to investigate genetic variation in black wattle seed sources for economically important traits and use that information for a breeding strategy. Okay, so the study included a total of 110 open pollinated families. 61 of them originated from mid to high altitude provenances in New South Wales and Victoria, and from 3 Tasmanian provenances, and another 49 South African first generation families, which were collected in a trial established in 2002 with seed from 2 hardy or cold hardy Australian provenances, which are Lake George and Mittagong in New South Wales, together with seed collected or seed from wild trees collected growing at very high elevations in the Drakensberg Mountains in South Africa. Okay, so we established 5 trials during 2014 and 15 in sites affected by severe frost in northern KwaZulu-Natal and southeastern Mpumalanga in South Africa. The number of families tested in each trial ranged from 33 to 107. Experimental design was randomized complete blocks with line plots of 5 or 6 trees and 4 to 7 reps. The trees were planted at 3 by 2 or 3 by 1.5 meters spacing. One of the trials, the trial at Inwe, consisted of seedlings placed in trays during winter in a farm affected by frost. Okay, so this is a picture of one of the trials. This picture was taken before the start of the winter. We measure survival. I mean, just for us to identify any dead tree before the occurrence of frost, and we measure also height before winter as an indicator of tree hardiness. We measure temperatures at 60-minute intervals using miniature sensors from April to the date of frost damage assessment. Okay, in this particular trial, we had in April several light frost with temperatures ranging from -1 to -2.1 degrees Celsius, followed by several frosts during May with temperatures going down to -5. And then in June, we had this trial had heavy frost events with minimum temperatures reaching -8.7 degrees Celsius. So this site in particular had a total of 27 frost events. Okay, we employed a frost damage score based on changes in the foliage, changes in the color and texture, as well as the strength of frost damage. So in a categorical scale ranging from 0 to 7. So this picture here shows a seedling showing a extreme frost damage, whereas this other picture is of a seedling showing some frost tolerance. Okay, okay. This is a picture of another trial in after frost damage. So the plot on the left is showing extreme frost damage, while the plot on the right is showing some frost tolerance. This site had a total of 30 frost events with minimum temperatures reaching -6.5 degrees Celsius. Okay, this is another trial in which the trees at the front are showing some moderate frost damage. The trees are bigger than the other trials, as you can see, because we planted this trial early in the season. Okay, so this site had a total of 42 frost events, and with minimum temperatures reaching -6.1 degrees Celsius. Okay, right. Now, regarding rust, we measure rust at 14 months of age using a score with a categorical scale representing approximate percentage of the foliage covered with tilia, and we assessed rust in two opposite sides of the tree. From this assessment, we derived, rust incidence, we basically means presence or absence of the rust in the tree. We also assess merit insect damage with a severity scale, as well as merit incidence. Okay. We evaluated tree height, diameter, breast height, stem form at 39 months of age, and together with gammosis incidence, which is this picture on the bottom. Gammosis is an old disease affecting black wattle, and it's caused by a complex of fungi, including Fusarium, Diplodia, and Phytophthora. Plus, it's associated to physical damage on the trees and some environmental factors. All right. So for data analysis, we ran a combined site analysis to estimate variance components and genetic parameters using ASREML version 4.1. We used generalized linear mixed model for binary traits. The binary versions of rust and merit produced better estimates or heritability estimates than the categorical versions. These other traits, frost score, DBH, height, and stem form, were analyzed with linear mixed models. And for all the traits, model selection included model convergence in best fit using the AIC criterion. The genotype by environment interaction was estimated as the average additive genetic correlation between pairs of sites for those models who provide all this information, or just the traditional method using the variance components of family and the interaction family by site. ASREML produces blobs of family effects, which are equivalent to GCA values, and we use multivariate models to estimate additive genetic correlations between traits. We also ran individual tree models for the estimation of tree blobs. And finally, we were using the predictive reading values of frost score, rust, and height. We scale them or standardize them to a mean of 100, and using 3 weights for for a selection index. Okay, right. This plot, let me just explain what the bars are. The bar in dark orange is Lake George, LG, and the one here in dark blue is MIT Michigan. These two are well-known cold hardy Australian provenances. The light orange one is first generation from Lake George grown in Australia, and mid F1 is first generation from Michigan. These two first generations, as I mentioned before, are families grown in a local site in South Africa, in a local warm site. These other 3 graphs are the progeny, or are families from the progeny of these wild trees growing in high altitudes in the Drakensberg Mountains. As you can see in the graph, Lake George was significantly different to the others and was frost hardier than the other ones. It was interesting to note that the first generation families from Lake George grown in South Africa were significantly less frost hardy than the provenance of origin. Okay, right. This graph is this shows family variation in frost damage. Okay, so as you can see, there was a wide range in frost damage, ranging from 1 to 3.9. There were 9 families from the provenances Lake George and Kuma showing distinctly less frost damage than the others. Okay, this graph is of the probability of rust incidence of all the families tested, and as you can see, there was also a very wide range in rust incidence, with the number of families showing high resistance on the left, okay, and also many others showing high incidence. Okay, these are the narrow sense heritabilities in family, in the repeatability of family means, as well as the G by E interaction. Okay, frost damage showed a moderate narrow sense heritability and high repeatability of family means, suggesting that this trait is partially under genetic or additive genetic control. Rust incidence was under a strong genetic control, as indicated by both a very high narrow sense heritability and high repeatability of family means. There was moderate genetic control for DVH height and gamosis, but low for merit in a stem form. Genotype by environment interaction was low for frost damage, rust incidence, and growth traits, and it was moderate for merit, stem form, and gamosis.
Excuse me, Julian, you have 2 more minutes.
No problem. Yep, getting there. So in terms of genetic correlations between traits, frost damage had very weak relationships with the others. Rust incidence also had low or weak correlations with the other traits. There was the 2 more important things here. Predicted gain from selection index, okay, using a breeding population, 135 trees from the best families, produce a 14% gain in frost tolerance, 15% in rust, and no gain in heart. The highest genetic gains were produced by clone selection, with 30% gain in frost tolerance, 24% in rust resistance, and no gain in height. So in the short term, the highest genetic gain can be produced by clones. I'm gonna jump this slide so I can go to the final one, okay? Conclusions. All right, so there was considerable genetic variation among seed sources and families within seed sources for economically important traits in the population study. So recurrent selection will be successful in improving frost tolerance and rust resistance. However, and very importantly, the current population comprises very limited germplasm that is both tolerant to rust, tolerant to frost and resistant to rust. So therefore, it's important to infuse new germplasm from non-cold hardy Australian provenances into the current population. It's also recommended to use artificial screening methods so to reduce the breeding cycles. I think that will be the most important conclusions. Yes, that's the end of my presentation.
Thank you very much, Julian. Any questions, Paul? I hope that everybody is awake. Although this is afternoon sessions, I'm not very sure. Julian, you are still live from South Africa now?
Correct, yes.
What time is this in South Africa now?
It's we have six hours difference. So here is 8:38 in the morning.
Okay. In the morning, okay.
Yeah.
Thank you for joining us from South Africa.
So yeah, I'm just waking up while you guys have after lunch. Yeah.
Okay. I just want to ask you a question. You presented just now a lot of provinces, but most of them is actually susceptible to rush infections. Correct? Am I correct?
Sorry, can you repeat your question, please?
Most of the provinces that you try is actually susceptible to rush infections.
Mm-hmm. Okay.
Is that correct?
What happened is, what we found is that most of the frost-tolerant provenances, okay, showed poor growth or below average growth and were rust susceptible. So we have some sort of adverse correlations at the seed source level or the provenance level. That's what we found.
Oh, okay. So that's why you proposed in your conclusions that more new materials is being introduced to South Africa, so that increase the genetic variations there.
Yes, that's right. So this is the second part of the conclusions. And well, basically what I just said to you is the second bullet point. And it's actually quite interesting and quite important. But yeah.
Okay, thank you very much. I don't see any question from the chat or Q&A. So thank you very much for your presentations. I've enjoyed your sharing. Thank you very much, Julian. So we move papers. The paper will be on eucalyptus alternative to Acacia mentioned in tropical wet climate. This presentation will be presented by Dr. Arno Brunner. He is senior forest geneticist from GP Pusaka based in Bintulu, Sarawak, Malaysia. Allow me to read his short CV or biodata. He was born in Germany, graduated in forestry in Brazil in 1967. Master in forestry from University of Washington, USA in 1970, the year that I born. PhD in forest genetics and physiology from University of Florida, USA in 1973. I have been a lecturer on forest genetics for a long time in Brazil. 20 years with German technical corporations in Paraguay, Argentina, and China, and also working few years in Africa, in Mozambique and Ghana. I have more than 60 scientific publications currently based in Malaysia. Now I invite Arno to present. Please, Arno, the floor is yours.
Can you hear me?
Yes, yes. Hi, we meet again.
I first would like to thank the organizing committee for allowing me to present this paper to you. And then I also thank GP Pusaka for letting me represent the company at this Congress. And finally, I want to congratulate the organization for a fantastic organization and very good papers which I have seen so far presented. So, can you see my slides? Can you see that?
Yes, yes, we can.
Okay, my topic is eucalypt alternatives to Acacia mangium in tropical rainforest. That is called the AF climate according to the Köppen classification. Just to go through that quickly, the tropical rainforest, AF is a climate without any dry season. Then we have AM, which has a monsoonal dry season. We also will talk a little bit about the CWA, which is usually the subtropical areas where eucalypts grow very well in Brazil and also South Africa, although there are other climates. And then maybe I mention very shortly the temperate and cold and dry summer, CS climate, which is the Mediterranean climate. Now, I would like to mention that the forest area in the world is huge, and very small part is only the plantation forests. But when we look at the production of the plantation forests, we see quite something different. We find that the majority of the products really come from plantations and not from the natural population. So the planted forests in the world with only 7% of the area produce about 70% of the world's forest products. This is very important for us to know because especially when we work in exotic species, we're always confronted with the question, why don't you just work with the native forest and instead of all these exotics? Well, exotics and the plantation forests really are the ones which produce the material which we use, and we want to save the rest for nature. Now, when we look at the natural forest again, we find that all over the world, it increases only from 1 to 5 cubic meter per hectare per year. While the planted forests, they produce something between 15 to 40 cubic meter per hectare per year at age 6 to 7 years. Now, looking at the plantations in Brazil, where I come from, that the eucalyptus plantations in Brazil produce something like 30 to 60 cubic meter per hectare per year at age 6 to 7 years. That is a fantastic productivity, but not in the climate we have here. In the Sarawak, we have mainly AF climate. This is CWA climate. So AF climate has not only a higher temperature, but a very high precipitation and generally poor soils. Now, looking at Emangium, it has some advantages: very fast growth, wide adaptability in AF climate, not very demanding on soil and fertilizer, and its nitrogen fixing. The disadvantages: high susceptibility to several diseases. And I want to remark here that in 1998, Dr. Harwood in Kuching already, when saying yes, mangium would be okay according to the data available at that time, but many diseases would be expected. So in 1998, he already said that. There is low genetic variation for disease resistance, although we heard yesterday from Mr. Lapamu that yes, there is some disease resistant which can be used. It's very hard to hybridize except for auriculiformis. It hybridizes with very few other acacias, and it's difficult in vegetative propagation. So what's the way out? We can use the hybrid A. mangiiformis, or we can try different acacias, like Crassicarpa is being very popular now. There are some more, also Peregrina, which I did not put here, and Acacia coa, which is hardly known, but it comes from Hawaii, from a wide range of altitudes, and the low altitude could do well in this climate. So if somebody still wants to try some new acacia species, this is what I would recommend highly, to put this one also. We could plant a mosaic. We could alternate rotations. We don't know so much about that because it hasn't been done so much that I know of. And we could consider eucalyptus species and hybrids as an alternative to manju. Okay, now what's the advantages of eucalyptus? We have many species to choose from. They're easy to hybridize, mostly easy for vegetative propagation. Most species have a wide genetic variability to choose from. Much experience in the subtropics, high productivity achieved in the subtropics. The disadvantages are there are few species adapted to AF climate, to our climate. They are more demanding in soil and fertilization than acacias are. They are sensitive to weed competition. There's not so much eucalyptus experience in AF climate, except usually for Pelita. And there are many pests and diseases also. So here, very quickly, I go through the main, this is from Harwood to 2011, where he looked at the range of temperatures of many species. We see that Pelita is the highest one here, but not bad is also Camaldulensis from the northern provenances in Australia, which means subspecies Acuta, Simulata, and Obtusa. There are 7 subspecies in Camaldulensis. Then you see that Ptereticornis is fairly high, Europhila also, but some of these species demand a dry season in between the rainy season, so not always convenient for our climate. Now, looking at our soils are poor. I will not go into the details of this here, but I just want to call your attention at the available phosphorus. It is 1 ppm or trace. And this is a good site for eucalyptus here, which I'm showing you. Okay, Eucalyptus Pelita does fairly well in this climate with a little bit of fertilization in the beginning. You can also look at the clay content down there, which increases with depth. Clay content fixes phosphorus. It also is fairly impermeable. That means little oxygenation to the roots, which is a bad situation, really. Now, if we look at the nutrients in the leaves, which tell us much more about the availability of what the plants really can extract from the soil, that soil which you have just seen, gives us the foliar analysis like here. You see that phosphorus is very low, but it doesn't tell us much if we don't know what is the ideal levels. What should be the ideal levels in eucalyptus if we have a totally well-nourished plant, healthy plant with all the nutrients available. There you see that we are low in nitrogen, phosphorus, potassium, especially. Then phosphorus, terribly low, and boron, copper, and iron especially. These are the ones where we really lack in our soils. So we have a lot of work to do in the soils. Now, the species adapted to the tropical rainforest come from climates similar to what we have here. And here you see that Pelita, which I call Pelita biterranea. Why do I call it that like that? Because it has been separated by Hill and Johnson in 2000. the Biterrania from Pelita. And that what we have here is not Pelita, is Biterrania, but it's not everywhere accepted and everybody knows it as Pelita. So in this work, I'll just speak about Pelita Biterrania. But the tropical, for AF climate and for AM climate, it is Pelita. It's not really Pelita, it's Biterrania from Papua New Guinea and northern York Peninsula, north of 15 degrees. We also have the Glupta, which we know comes from all the way from New Britain and Sulawesi Island, Seram Island, and Mindanao Island in the Philippines. It's the only eucalypt which naturally crosses the equator. Then we have Eucalyptus brasiliana, which is very interesting for us, especially the Papua New Guinea provenance, if we can get these provenances, and Tereticornis also from Papua New Guinea. These two species, I'll speak a little bit about them because they are of the subsection Excertaria, which is very well adapted to poor soils and to very impermeable soils like we have here very often. Then there's a possibility with Eucalyptus leptophleba. I don't believe too much in it because it's a medium-sized species, and I don't know of any trial for plantation with it. But anyway, I name it also because it would also be a species adapted to our climate. Now, all of these four species in the beginning, Pelita biterrania, Deglupta, Brasiliana, Tereticornis, they can cross with each other and give very vigorous hybrids. As a matter of fact, the Filipinos in the 90s with the Glupta and Pelita or Biterrania, they made very good hybrids, and also with Europhylla. I will not go into this now. This is just a classification of the eucalypts of those which are mentioned. They will be in the paper if in case this paper is published by the journal. Now here we have a picture of Pelita or Pelita biterrania at 6 years in our area, and you have a mean annual increment from 10 to 20 cubic meters per hectare per year at age 6 to 7. And the wood density is very high, 650 kilograms per cubic meter on average. This is very good. So this growth here is not fantastic. You see that the weeds are still a problem for us, although they have been killed at this moment. But weed and fertilization is a big problem for us in Sarawak. And here you see also the Glupta. The Glupta goes far higher. The Glupta goes to even 47 in one of our plots, 25 to 47 cubic meter per hectare per year, but the density is much lower. When the Filipinos crossed the two species, they had even more growth from the hybrid and a density in between these two species. Now the hybrids, you can do the hybrids between all these species here. We don't know very much about the possibility of hybridizing leptophleba if it came into consideration. But these eucalypts can be crossed among themselves. As I said, Pelita biterrania and Deglupta give a very good hybrid, but also Brasiliana. We have a few hybrids of these, and they are always better than the surrounding Pelita around them. Tereticornis has not so much been tried, at least not the one from the tropical environment. And finally, we can cross all these eucalypts with the subtropical ones, Europhylla, which demands a dry season. Grandis, Saligna, Camaldulensis, they don't grow here, but we could import the pollen. And then we can also cross them with the section Maidenaria, which is usually the cold climate adapted eucalypts, with some with very good pulping characteristics like Danii and Globulus and Nitens. So these can all be crossed into that. So if we have these growing here and producing flowers, we could import the pollen from these here from areas where they occur. We can make two-way hybrids. We can cross a hybrid with a third species. So we have three-way hybrids. It can be two hybrids, different hybrids in the four-way crosses, and we can do back crosses. So the possibilities are immense. And for AF climate, for our climate here in Sarawak, we should start with the species adapted to this climate and then import the pollen to widen the gene pool. Now, what's the course of action? First, we need introductions mainly from Papua New Guinea. We really need this. We need it from Raciana, from Pterygicornis, possibly Leptophleba, but also more from Pelita. From Pelita biterrania, we already know that that is the best provenance. The rest will also certainly be the best provenance. Now, the Glupta has a whole gap of provenances. I have never seen any Deglupta planted from Sarawak Island, from Seram Island and Sulawesi Island. Sulawesi Island is very close to us here, and that's where it crosses the equator. So it should be interesting to get these Deglupta from there before they disappear. We have to test all these species in many locations. We have to produce the land races of them and start breeding programs with equatorial species. As soon as possible, hybridize them. And there is no need to wait until 20 years. Whenever there is a promising clone, we can start propagating it. But we need a very, very wide genetic base to start really a good program with cloning and hybridizing to overcome the constant disease threats which we have here. Now I'll go into Corymbia. Corymbia is not so much talked about, and I don't believe in any of the species in here, except possibly Torreliana. Torreliana might grow, but will not probably be the best. But there are some Corymbia which come from Papua New Guinea also. And these are the ones we should concentrate on. And then the hybrids, especially the hybrids. Torreliana crossed with spotted gums, which are Citriodora, Variegata, Maculata, and Henriette. They give excellent hybrids. And some of these hybrids are growing in very tropical areas like the Amazon area already, and also in Congo, but not very much. But I'll give you another example from very close by soon. Now, the difficulties with Corymbia, they are not so easy to vegetatively propagate. So we can use mini tunnels for mother plants, and I'll show you a picture of that shortly. We can use the cuttings from lignotubers, and we can use Torreliana as the mother plant in the hybrids for maternal inheritance, because Torreliana roots, while Citriodora, for instance, Henria and so forth, they don't root very easily. Here, this, I don't want to go too much in this. Here they cross Torreliana with Torreliana and compared when using the pollen from very different species in the Corymbia. And you see the two sections, Blacella B and Corymbia section C, and they are spread all over. I expect that the classification of the Corymbia will change still. It's a very interesting paper, but we cannot go into it in detail here. Now, this is a mini tunnel where you keep the mother plants of, in this case, Citriodora, which is very, very difficult to root normally. And you put them in these mini tunnels, you keep this hermetically closed. And if you do it by the proper way, the usual way, you hardly get any roots, if at all. While from the mini tunnel, you get normal rooting, very good rooting. By the way, this mini tunnels, that also works for other difficult to root eucalyptus. It has the same effect on them also. So it's a very interesting technique to be used. This was done by my student, Teotonio Assis, who was my master's student and my undergraduate student in Brazil, and he is very famous nowadays. I'm not, but he is, and I'm very proud of that. Here is Citriodora from the cuttings, from the mini tunnels. You see everything rooted, very, very good rooting. So the mini tunnels work very well. Here you have Corymbia torreliana times Citriodora clones in Brazil at almost 1 year of age. Very healthy, very productive. The high density of the wood and the low splitting of the wood is really a fantastic combination. Here you have the same plantation at year 7 years. So this is a clonal plantation of Corymbia torreliana times Corymbia citriodora at 7 years. And here I want to show you a torreliana citriodora, which I sent the seed to Kalimantan. And there, this tree in the middle is the one growing there, growing very well, much better than the Quelita clones, which are also selected material in the background. This was what I had. I think as conclusions, we don't want to avoid, if we want to avoid the mistakes of the past, planting one species on large areas. There still are hopes in acacia, hybridization, different species. There is genetic variability offered in the genera Corymbia and Eucalyptus, which has not been used hardly at all. There are still many provenance gaps of equatorial eucalyptus here, especially when it comes to Sulawesi Island for the Glupta and also for Papua New Guinea for all the other eucalyptus species I mentioned. We need to research much more in nutrition in this climate. Hybridization and vegetative propagation are very important assets that has been extremely successful for the subtropical eucalyptus, and the same can be done here because I showed you already that you can get 47 cubic meter per hectare per year under special conditions here. And we have to find a way to import pollen because that is not an easy story. If you import seed, they have to be treated with chemicals. Pollen you cannot do like that. So I think there is not much information on how to import pollen if we want to make hybrids. This was really what I wanted to present to you. Thank you.
Thank you, Arno. Very well presented. There is 2 questions from you to you actually, and now it's 3. First questions from Doringo. Instead of eucalyptus as alternative planting material for plantation, won't it be better to focus more on indigenous species with known growth and wood properties?
Sorry, the question was there is Eucalyptus pelita, and if there isn't.
No. It is actually instead of you promoting eucalyptus as the alternative source for plantation.
Yes.
The suggestion is that we consider indigenous species instead.
Okay, my reasoning goes like this. If you have an indigenous species which gives you the productivity of the eucalyptus, well, why not? So first we have to have them, because as I showed in the beginning, the plantations are really producing all the wood, practically 70% of the wood in the world. So it comes from plantations. But yes, if you do have an indigenous species, I will not argue it would be better. Probably they will have to be planted in monocultures as well. So they might have their own problems. I have nothing against them as long as they produce what you can get from other species also. Why not?
Yeah. From Kin, from Vietnam, he actually asked you, can you please explain more about the mini tunnel, how it is different from normal propagation technique?
Yes, the mini tunnel, in the mini tunnel you have a small tunnel like I showed in one of the last slides. which is kept at no more than about 50 centimeters of height, completely closed with plastic and hermetically closed. You keep the plants in there. You can open it once a day and irrigate whatever has to be done. And that is the way they are kept. So the morphology of the leaves changes a little bit. They get a little bit more narrow. They get a little bit, the color changes a little bit, but the rooting is fantastic. And the same technique, as I said, works for hard to root eucalyptus, like Louisiana, for instance. It works for them as well.
There is a third question, Andrea. Actually asking you, do you know any trials with genetic material of Eucalyptus tereticornis from Papua New Guinea?
No, I don't. As a matter of fact, it's very difficult to get these material, any material from Papua New Guinea. But I would leave my suggestion here that for our climate, for Indonesia, and for Malaysia, possibly Vietnam, possibly Thailand, it is very important to get this material. So if there was a concerted effort to obtain this material from there, possibly with the help of the Australians who have some of it, that would be very important, yes. But I don't know of any tereticornis from Papua New Guinea installed anywhere around here. But it should be.
Thank you very much for the presentation. Thank you for the answer. I believe that everybody actually get a lot of information from your presentations. So without further ado, we move to the fourth presenter for this afternoon. Again, I will invite Dr. Hash to present his paper, this time entitled Evaluation of Early Growth Performance of Acacia auricariformis clones across constructing sites in southern India. Please, the floor is yours. Mahendra? Are you, okay, thank you. Please unmute your mic. Okay. We seem to have little technical issues here. Stop sharing again, or this one, organizing committee, do you have Dr. slide?
Yes, we can share from our side.
Okay, Dr. Hash, please stop sharing. Hash, what? Hello? 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 Are you there?
So I think our speaker temporarily lost connection. Do give him some times.
Is that he's trying to log in again?
Dr. Ong, maybe we
Yes.
proceed to the next speaker first.
Yes, okay. I would like to, Dr. Kamal, are you around? Are you ready? Dr. Kamala?
Yes, I'm ready.
Okay, I will invite you first to present your paper on conversion of a progeny trial of acacia mangens to a seed orchard, considering gain and fertility. Dr. Kamal is actually a scientist at the ITC paper box and specialty paper divisions in India. Allow me to read his CV. He's completed his PhD in forest genetics from Forest Research Institute, University in India, having 22 years of research experience in pulpwood tree improvement program and eucalyptus seed orchard. Published a lot of peer-reviewed papers. He also established eucalyptus and casuarina species that with the objective to produce high-quality seed. Recently developed high wood and pulp yielding clone and deploy them commercially. Please, the floor is yours. Dr. Ratinan.
Yeah, thank you, moderator. Good afternoon to all. I'm audible?
Yes, please continue. Are you sharing? Yes, okay.
Is my slide visible?
Yes. Please share the slide. Yeah, okay, thank you.
Yes, good afternoon to all. Thank you, moderator, for your introduction to the forum. And also I extend my sincere thanks to the organizing committee to permit me to present the work to this conference. So here I would like to explain the work we have done in Acacia mangium species. And this species actually grown in India, introduced to India in 1980s. Our previous speakers introduced about the species a lot about, so I'm not going to details. The species introduced to India 1980s. At that time, the source was not unknown. That the growth also very poor and stem form is not excellent. So with the CSRO consultant, Dr. Chris Harwood, the support, we have introduced the material from Papua New Guinea and Queensland. This has established the trials in the western part of the country and subcontinent. So the breeder's requirement is seed, immediate seed production. We started the seedling seed orchard from the first generation progeny trials. That is the easiest way for the breeders in the short-lived species like Acacia, Acacia, and eucalyptus. So in this Acacia, we have introduced the material, and the first generation material was converted into seedling seed orchards. And the seeds is supposed to be superior from seedling seed orchards because so many families introduced from the resource. Generally, before going for the seed orchard establishment, we have to see the methods to convert the progeny into seedling seed orchard. And that gain is very important. Gains beyond the first generation would be depend on the accuracy of the selection procedures, selection of the genotypes, and the management in the inbreeding should be avoided. So gains will be cumulative in the first and the subsequent generations. For that, we have used two different methodologies, like a truncation and phenotype selections. In the methodologies really helped us to get the, especially for the tree breeders, help us to get the gain as well as the diversity. In addition to the selection methods, we have to consider the fertility of the trees. See, after selecting the tree is not fertile, so we are not able to get the quality seeds. So ultimately, fertility is also very important. So we consider the fertility of the individuals in the first generation material. So that will transfer the genes to the next generation crop. So in this study, we aim to predict the impact of the selection methods. Two selection methods we deployed. So that is impact on the gain and as well as the diversity in the first generation of the trial at the age of 7. Coming to the materials are introduced from Queensland and Papua New Guinea. The tulimicin and the pasco ore material from the Queensland source introduced to the western part of the subcontinent. So these trials are established so many places, but the orchard study taken from one place called Nilambur. So that there is a material planted in the high rainfall area, and this same Papua New Guinea sources also, the altogether 20 families we have introduced, and this was replicated 4 times. Each plot has a 8-tree plot. The spacing was 3 into 1.5 meter. So this is the material we used for the study. So that site, about the site, that is a high rainfall area. And the average, the total annual rainfall was 300 mm. It's on par with our Papua New Guinea source. The temperature, average temperature, mean annual temperature was 29 degrees. So the wettest month is the June. The driest month was February. So here the flowering starts in the month of May, June. After 4 months, we have recorded the fruit set, the pod production. So this also actually good for the trees growth, as well the seed set was not as encouraged because of the high rainfall that conditions. Then assessment, actually we have evaluated the trial was evaluated every year, but at the age of 7th, we taken the data for the conversion of the progenitor into seedling seed orchards. Also, we recorded the pod production in the per tree at the age of 7. So if that is very difficult part, actually we used a pair of binoculars. We just counted the branches and the fruits in the branches. Sometimes when we face the difficulties, we engage a climber and cut the branches, the middle part of the tree, and just counted the pods per tertiary branch, number of tertiary branch with the pods presence in the secondary branch, and a number of secondary branches present in the primary branch. So also we have the pods. So like that, we have recorded the data, and that the data was extrapolated using this method, like Bilag et al. Professor Kang and Lindgren developed a method to extrapolate the fertility variations. So we have used the parameters like a fertility variation, relative population size, group ancestry. These are the parameters help us to understand the orchard dynamic, and these parameters values help us to understand the variation in the fertility. Generally, the sibling coefficient value, probability of 2 genes originate from the same plant, was used to quantify the fertility differences between the orchards. Actually, this can be estimated the sibling coefficient value, the number of trees present in the population with the flower production, so or pod set. Then this value you can get it. This, if it is the 1, the sibling coefficient value is 1, is the orchard is equally contributing. So again, the relative population size. The relative population size gives the idea about the genetic, the diversity in the populations. So number of effective trees contributing from the stands, and as well as the random mating with the actual number of trees in the orchard. So this get an idea. The method developed by Professor Lindgren in 1996. We used this theory to develop the this relative population size. Also, the group consistency value, formula developed by Lindgren and Mullin, Professor Sweden. So this also brought up 2 genes taken randomly from the gene pool of the expected seed crop will be the identical descent. This given the relationship between the individuals. So coming to the results, when we study the growth of the provenance introduced from the Australia and Papua New Guinea, so the growth at the age of 7 in terms of height is not much varying. When the diameter breast height was higher in the Papua New Guinea material than the Queensland material. Similarly, the pod production as well as survival percent also higher in the Papua New Guinea materials. So generally the trials average survival was 64% at the age of 7. It was ranging from 34 to 85%. Here we use this DBH parameter for selecting our trees to convert the progenitor into seedling seed orchard. Just we want to see the correlation between the phenotype and the fertility of the tree. When we see the growth between this height and DBH, we are having the positive correlation, but it's not statistically significant. But same way, the pod with the height and the DBH is 0 as well as a slightly positive side, but it's not positive correlation. This is also one way good, and we selected based on the growth of the tree. See, all the trees are having fruit production in the selected populations. When we saw the percent flowering trees in the families, when we study in the 20 families, the percentage varies from 31 to 84. Trees which is introduced from Papua New Guinea shows good fertility compared to the Queensland provinces. But in general, all the families are having the fertility, having the fertile trees. And coming to the fruit production in the tree, it varies from 2% to 11%. Here also the fruit production is not significant in the growth. So we use this parameter to just count the fertility and seed production capacity of the tree. So overall, all the families in the trial were fertile and produced seeds. Coming to the parameters studied, so number of trees actually before thinning the orchard, after 60% survival, we had 405 trees, and we used a truncation selection. Then the truncation selection was select families only based on the merit. Above the trial average, what are the families having the trial average mean value in the growth? We got selected. We retained 270 trees. But the phenotype selection, we didn't consider the family merit, but individuals' value were taken up. There are individuals represented from the inferior families. Then the fertility value is the very important. And actually, before thinning, it was 3.7. The truncation is not much varying, again, on par with 3.7 to 3.4. The phenotype value selection gave 3.1. And the relative population size in terms of diversity, it gives 0.27 when the existing trial. So after thinning, after the truncation selection thinning, it was 2.9. But the phenotype selection gives more percent, 32% higher we got it. Group consistency also on par with the trial. Actually, the existing trial has 0.033, but the phenotype selection got 0.035. But the truncation got more because there we lost a lot of families because of the inferiority. Growth already I explained. Actually, growth was 19.1 centimeter dBH in the truncation selection. The phenotype selection we got 21%. That is 16% higher gain we got it compared to the truncation selections. When we retain the families, before thinning we got 20 families the introduced trial. So the truncation selections we thinned the inferior families. We were able to retain only 15 families. But in the phenotype selections, we retained all the 20 families, but the number of trees varying. It's a 14 to 27 trees are there. So this we able to get all the families in this selection, and we able to get the more gain as well as the fertility sibling coefficient value also on par, lesser than the existing trial. Coming to the breeding value of the selected trees. So this number of trees having the low breeding value in the before thinning strategy. But the truncation selections all are above on the average. Above average only it's retained. But in the case of phenotype selections, a few trees coming inside the low breeding value. Since the trees selected from the inferior family, the value is very low. But most of the trees are more than the 197 trees, around 150 trees are falling in this positive breeding value category. So even that it is a negative, but all the trees are fertile. So this is helping us to get the gain and the next generation. The cumulative contribution curve explains the relative proportion of the individuals accumulated gametic contribution in the selected populations. So in an ideal situation, this is expecting an equal contribution of all the individuals in the selected populations. If it is so, the sibling coefficient value is 1. That time the line should be straight. But in our case, the before thinning, it was deviating from the 1, but it's showing around 80% of the trees having pod and fruit production. But in the truncation selection, we got slight improvement. The sibling coefficient value was 3.4. But after phenotype selection, it is 3.1. So still we are deviating from the equal line. But the thumb rule actually, according to the Professor Kang and Lindgren, ceiling seed orchard sibling coefficient value supposed to be 2. But this is not far away from the 2, it's 3. So this can be improved, the mixing of 2-year seeds for further improvement program. In conclusion, actually, compared to the both provenance materials, PNG seedlets having better growth, survival, and fruit production. And there was no significant correlation between the growth and fertility. So then we taken the growth phenotype selection for the converting the progenitor into seedling seed orchard. We got 16% gain in terms of growth, and expected the diversity was 32%. So these are the results we obtained. That's all from my presentation. Thank you.
Thank you very much, Dr. Kamal. Any questions from audience, from our participants? I hope that you can post some questions regarding the conversion of progenitor trial of Acacia minjan to a seedling seed orchard. So explaining some gains and fertility of the species that they were able to get from converting to seedling seed orchard. Any questions? If no, we will wait for them to post into our chat or Q&A. Later, Dr. Kamal can actually look at it and respond accordingly. Okay, thank you very much for your presentation.
Thank you, sir.
Kamal. Again, I would ask organizing committee, is Dr. Hesh is ready? Dr. Hesh is now?
Hello? Not yet. He's
Not yet.
Yeah, not yet.
Oh, so we move to the last presentation for today. Let me see. It's actually, I was informed that it's actually yesterday, but anyway, he will present on assessment of the incidence and severity of ants bleeding in plantation grown Eucalyptus pelita in North Borneo. Let me read his CV. I think Mr. Manuel SP is actually from Germany, currently working at Forest Solutions Malaysia Sdn Bhd as the logistic manager. He obtained his bachelor degree in forestry in Germany. Currently registered as a master student with the University of Putra, Malaysia, studying the ant splitting in this one, Eucalyptus pelita logs. He have 23 years of working experience, with 20 years in Malaysia, mostly involved in harvesting and log yard operation, plantation establishment, nursery plant productions, and R&D. Without further ado, Manuel, the floor is yours. Are you around? Yes.
Hello, can you hear me?
Yes, yes.
Yeah, I have some technical issues here, same as yesterday. My Zoom connection usually breaks off, so I'm not sure if I actually can deliver this today. I have some problems here.
Yeah, I can see you.
Yeah, okay, good.
Now,
yeah, so I hope, yeah.
Please continue.
Yeah, I hope I can deliver this now because I'm experiencing some technical issues here. The line quite frequently breaks off. Okay, I can't see my slides at the moment.
Organizing committee, can you help to share?
Sure, sure.
Yeah, okay. Can you see the slide?
Okay, yeah.
Right? Please continue. What happened?
Hello?
Yes, yes. Please continue.
Okay, as said,
Probably because the line is not stable over there. Are you in Kota Marudu? Hello? Hello? Are we losing the connections? Organizing committee?
I think his line is not stable.
yeah, okay, I think
Organizing committee?
okay, so I'm sorry, I think I can't do it today. Maybe next.
Okay. Sorry about that. I think you are in Kota Marudu. Probably the line is not so good.
No, I'm in Germany. I'm in Germany.
Oh, you are in Germany. Okay. I thought you are in Sabah now. Organizing committee, since both of the last two presenters are not able, I pass back to you, MC.
Mr. Manuel, can you off your video? Mr. Manuel, are you still there?
He can't do it.
He can't do it.
Yes. So I pass back to this one, our MC for today.
Okay. Thank you, Dr. Ong. Thank you very much for your kind contribution to the conference as the moderator for today. So, as we all know, sorry. Ladies and gentlemen, on behalf of the organizing committee, we would like to apologize for the technical hiccup that we experienced with Dr. Manuel as well with Dr. Maheshwar. But I would like again to thank Dr. Ong for facilitating these quite heavy sessions. It's on genetic and breeding and it's quite technical. Even for us here, it's something that a difficult thing to grab, but to all speakers, a big thank you and appreciation to Dr. Anna Malai, Dr. Julian Moreno, Dr. Arno from Bintulu, thank you very much. Dr. Maheswar, Dr. Kamalakan, and Mr. Manuel, although you could not present, we hope that we can see you in other event here in Kuching for a very accelerating research, insight, and funding. So now it's still 3:36 p.m. Malaysia time. We are supposed to have a poster sessions at 4 p.m. Poster. Can we have poster now or rest? Poster. Okay, we will be resuming this conference with the poster presentations. So. there is exciting information that we received that Dr. Maheshwar will be joining us later, but we will continue first with poster presentations. So each poster presentations will be given 5 minutes to share their research findings. We will not be having any questions and answer session. However, we hope that you can correspond with the poster presenters through their email, which can be sourced from the digital program book that we sent earlier on. I believe all poster presented here today have a very interesting finding indeed. Give me another 1 minute, sorry. Okay, first we have Ms. Nadira Muhammad Nunus, a postgraduate student from Faculty of Science and Natural Resources, University Malaysia, Sabah, Malaysia, with a poster titled Identifications and Characterizations of Fungal Pathogens, Ceratosis Species on Acacia menjum in Ulu Kukut, Sabah.
Hello everyone, my name is Nazira binti Muhammad Yunus. I'm a UMS postgrad student. My research is identification and characterization of fungal pathogen Stratocystis species on Acacia menjum in Ulu Kukut, Sabah. Acacia menjum is known to have major fast-growing, tropical greening, good wood efficiency, and less selectivity on environment to grow. However, such a huge monoculture, there is emergence of some pests and diseases that are now posing a big challenge to plantation industry. And one of the challenge is wilting phenomenon that are related to Stratocystis. The first significant incidence in Malaysia was reported in Tawau, Sabah, about 40%. Signs and symptoms of Stratocystis. For early stage, there is presence of cracked or sunken bulb near the cankers. Advanced stage show presence of blue-black patches on the cambium, gamosis, and fermented exudate. And lastly, if the tree is severely disturbed, it will eventually cause fatal. I collected wood cambium, roots, leaves, and soil underneath the symptomatic acacia tree as my samples to isolate the fungal pathogen. The growth diameter of the culture are taken for 14 days, and the characteristic and morphology of the culture are observed by its macro and microscopic features. As for identification through molecular markers, the fungal DNA was extracted, amplified into several copies of specific DNA segment by using markers, and lastly was analyzed using MegaX software against the NCBI gene bank database to identify the species. From my collected samples, I found 4 isolates with different macroscopic features, which is isolate 1 has mated pale olivaceous grey and the reverse side show dark brown to black. Isolate 4 has circular greyish that turn darker grey with age and the reverse side show circular brown to black. Isolate 5 has white coloured colony that turns to greyish brown with age and the reverse side show dark brown to black. And isolate 6 develop dark grey olivaceous colony with a brownish to black reverse side. As for microscopic features, it has more or less the same shape, which it has globous or opiriform bases with long neck, ended with divergent or non-divergent osteolar hyphae tips, and it also has conical spine base. Isolate 1 globus, isolate 4 globus, isolate 5 opiriform base, isolate 6 globus base. Next, this figure right down here show the average diameter growth between the 4 isolates within 14 days. As we can see here, isolate 4 and 5 have more or less the same growth, which isolate 4 reach up to 8 cm and isolate 5 7.9 cm. As for isolate 1 has the slowest growth among these 4 isolates. So based on this phylogenetic tree for ITS primer, we can see that isolate 1 is closely related to Ceratomeganicans and is more distantly related to Ceratophimbirata. As for these two species here, isolate 5 and 6 are closely related to each other and is more distantly related to isolate 4. And for the outlier species down here is the least related among the isolates that's gonna be the Aspergillus niger. According to phylogenetic tree for beta-tubulin primer, isolate 1 is closely related to Ceratopimbrata and is more distantly related to isolate 4. Isolate 4 is more distantly related to isolate 6. Isolate 6 is more distantly related to isolate 5, and isolate 5 is more distantly related to Ceratomeganicans. Aspergillus niger as the outliers. My conclusion, so far molecular identification for all isolates are still not conclusive and will be resolved by PCR and sequencing with third primer MS204.Cerato-B to confirm the findings. Acknowledgement to University Malaysia Sabah, Sabah Forestry Development Authority, SAFODA, and my grant research from UMS. Thank you.
Thank you, Ms. Nazira. The second poster presentation is from Mr. Agustin Alwi, plantation manager and silviculturist from Borneo Forestry Cooperative, Malaysia, with the title of Near-Infrared Spectroscopy for Rapid Assessment for Foliar Nitrogen and Phosphorus.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Hope you all are doing great and well. Thanks to IUFRO for giving me this opportunity to share the knowledge of research and collaboration between Borneo Forestry Cooperative and University Putra Malaysia. The title of my poster is Near-Infrared Spectroscopy for Rapid Assessment of Foliar Nitrogen and Phosphorus. As we know, site preparation and early fertilizer application of nitrogen and phosphorus on Eucalyptus pellita is essential when planting tree seedlings in commercial forest plantations. To monitor the response of fertilizer application, foliar samples are often collected from trees in designated fertilizer response trials to provide feedback on the availability of the nutrients. Foliar analysis is traditionally conducted using chemical method of analysis, which are costly and labor-intensive, destructive, and while high-throughput elemental analyzers are used, the sample throughput is limited. Near-infrared potentially provide detailed data in longitudinal studies. It is therefore desirable to implement a technology that is non-destructive to foliage and could be used for repeated measurements of individual leaves of a tree. The parable of near-infrared can be illustrated as an example, the red color. We're able to see the red color because green and blue light is absorbed and red is reflected to our eyes. Usually, it was measured in wavelength or sometimes in a reciprocal wavelength. In fact, near-infrared spectroscopy is already used in the forestry and wood product sector for rapidly and non-destructively predicting wood quality and wood properties. In this study, leaf sampling is divided into two stages, namely nursery stage at 10 weeks and field stage at 3, 6, and 9 months after field planting. Each stage was derived from fertilizer trial, consists of 4 treatments as shown in table 1. All treatments were designed based on standard operational practice, reduced to 50%, increased to 50%, and control, whereby no fertilizer application at all. Figure 1 shows that the process flow of calibration, development, and foliar sampling at nursery, field stage, and sample scanning using micro NER 1700 produced by VIB solution. NER spectra were acquired both fresh on the tree and again after air drying and grinding, and sometimes the data transformation are required. Young fully expanded leaf was sampled to standardize the selection of sampling. Foliar nitrogen and phosphorus were determined on a subsample of foliage following the methods of Jeddah and Bretu respectively. Partial least square regression analysis of the NR spectra and the nutrient values was performed using the unscrambler. In the result, like all fresh biological samples, the NR spectrum of foliage is dominated by the water absorbent band near 1160 and 1452 nanometer. The dominance of this band frequently degrades the overall performance of calibrations developed using NR spectra from fresh sample, so that drying and preparing sample often improve calibration performance. Nonetheless, calibrations of foliar nitrogen and maybe phosphorus are possible using fresh NR spectra of the foliage acquired in situ on the tree. In this study, calibrations developed using combined sample from the 10-week-old seedlings in the nursery and from trees in the field at 3 months and 6 months post-planting were used to predict the foliar nutrition using spectra acquired on the same trees at 9 months of age, as shown in Table 2. As a conclusion, calibration of foliar nitrogen and phosphorus on fresh leaves was successful for nitrogen and slightly problematic for phosphorus, which is consistent with NR foliar analysis in other crops. Using this method could provide a step change in the ability of foresters and agronomists to evaluate, control fertilizer trials, and optimize the application of fertilizer to operational areas by assessing the availability and demand for nutrients at local scale. Last but not least, we will continuously improve to develop the robust model for nutrients on Eucalyptus pelita across Sabah under collaborative program. Thank you. That's all from me.
Thank you, Mr. Agustin Alwi. Next, we have Mr. Megat Najib bin Megat Muhammad Nazir, a GIS Senior Executive from Borneo Forestry Cooperative, Malaysia, with a poster presentation titled Early Monitoring of Tree Health Status via Visible Spectrum Imaging of Tree Foliage using Unmanned Aerial Vehicles.
The title of my poster is Early Monitoring of Tree Health Status via Visible Spectrum Imaging of Tree Foliage using Unmanned Aerial Vehicle. As we know, field surveys are important for pest and disease detection. However, they are labor-intensive, time-consuming, and are not practical in areas with a particularly steep terrain. Therefore, precision agriculture technique using the high-resolution remote sensing from unmanned aerial vehicle with a variety of different sensors, or even the conventional one, red, green, and blue camera, will lead to cheaper and more practical monitoring of forest health. So in this study, an intentional decision to explore the capability of a ready, available, and affordable system without the need for expensive or sophisticated equipment such as a hyperspectral or manispectral camera to monitor the tree health status in the forest plantation. There are 3 objectives in this study. First one is to investigate tree health status of young Eucalyptus pelita using the unmanned aerial vehicle. The second one is to develop an index classification based on the very green algorithm in the young Eucalyptus pelita plantations. Last but not least, to investigate the difference between very green and normalized digital vegetation index in terms of index value signature relative to the tree health status. This study was undertaken in the industrial tree plantations of Brumas Estate, Sabah Sopus Berhad, and the high-resolution aerial image were acquired using UAV, namely a Phantom 4 Pro that equipped with the RGB camera. The aerial survey work was undertaken on 27 November 2019 with an altitude above the canopy is 129 meters. After the data acquisition process, images were processed using the Agisoft software to generate the orthomosaic. Then the image analysis was performed using the ArcGIS software. The Varigram index is a vegetation index produced entirely the visible region of spectrum and using the algorithm of green minus red divided by green plus red minus blue. This index will be generate a greenness level from which tree health can be determined. The higher the level of the index, the healthier the tree. Figure 2 show the procedure to generate Varigreen plot from the raw data. Varigreen output is produced the value from -2 to 2. From this data, the classification of tree health status was created based on the percentage of red in the Varigreen tree crown. In Block 42H, a total of 11,069 splitter trees were recorded, and 7 were classified as dead with the Varigreen value -2 to 0, and 5 were severely infected with the Varigreen value 0 to 0.05, and 967 trees were mildly infected with the Varigreen value of 0.06 to 0.1. Last but not least, around 10,000 were considered healthy with a Varigreen value 0.17 to 2. The resulting correlation between NDVI and Varigreen shows slightly difference by plot with the mean correlation value for the trial plot of 0.73. Besides that, we also do the accuracy classification assessment. We adopt a confusion metric and the kappa coefficients. The overall accuracy succeeded in identifying with more than 90% accuracy. And as a conclusion, without the need for more expensive hyperspectral camera, simple RGB image processed using the Varigreen algorithm were able to assess pest and disease early in the growth stage. The result of this study has shown that the infestation and infection of unhealthy trees in the industrial tree plantation could be detected with a Varigreen image obtained from a low-cost drone across the large area, 22.78 hectare. And that's all from me. Thank you very much.
Thank you very much, Mr. Megat. Next, we will have Mr. Hamzat Fahmi, R&D Officer from Borneo Forestry Cooperative as well, Malaysia, with the title of Near Infrared Spectroscopy of Plantation Forest Soil Nutrients in Sabah, Malaysia, and the potential for microsite.
Assalamualaikum and good day to everyone. I wish you all are well and staying safe and healthy. I am Hamzat Fahmi Ahmadjani, representing Borneo Forestry Cooperative. First of all, I would like to express my gratitude to IUFRO for accepting my participants in the 2021 IUFRO Conference poster presentation. Soil is principally a medium for plant growth, and soil fertility is the capacity of soil to provide essential plant nutrients to ensure optimum plant productivity. In other words, soil fertility represents the quality of a soil. This information can be obtained by analyzing a soil sample for its physical and chemical properties. So knowledge of soil physical and chemical properties is vital to the optimal growing performance of agricultural crops, including plantation forest trees. Near-infrared spectroscopy has been shown to be a tool that enables rapid and low-cost assessment of soils. However, its use in forest plantations has been slow to develop. This study shows the development of calibration for total organic carbon, total nitrogen, and soil pH, using a handheld NIR spectrometer for soils at 3 sites in Sabah, Malaysia. Methodology. As you can see in the diagram, this is the series of steps that has been taken to select the best model for this study. It starts from soil sampling, where we have collected samples from 3 sites within Sabah, and then we prepare the soil samples, and then we acquire the NIR spectra using the near-infrared spectroscopy. And the samples that has been scanned are sent to an ISO certified laboratory for compositional analysis. Once we have the data, we will run a multivariate data analysis that is performed using the unscrambler version 10.5. Once we run the data analysis, then we will do the calibration and validation, as well evaluating the model performance in order to select the best model for this study. Now let's go to the results. Based on the figure 1, based on the laboratory result, and as expected, total nitrogen and total organic carbon from A horizon are higher or more concentrated than the B horizon samples across all 3 sites. The correlations between organic carbon and total nitrogen at each site are moderate to strong. For the principal component analysis, by using the raw spectra, which you can refer at the figure 2, from the calibration set showed that samples were not spectrally distinct for the first 3 principal components, which together explain 99.7% of the total spectral variance. For partial least square regression of total organic carbon, total nitrogen, and pH using the spectra from dry soil, as shown in table 1, the results for root mean square error predicted values for organic carbon are similar to the reported calibrations in the neighboring country of Papua New Guinea and also in New South Wales, Australia. In the case of total nitrogen, the root mean square error predicted values is ranging from 0.02 grams to 0.05 grams in the A horizon. While for soil pH, although it was not validated with a test set, the root mean square error calibrations values is in the range of 0.14 to 0.17 pH units, which are comparable to other studies. So from the calibration and also model that has been developed, we try to use it for special mapping of a site, which we can look at the figure 3, which shows the NIR predicted values of TOC, TN, and pH for spectra acquired from A horizon in replicate 4 on the top of the picture, and also in replicate 8 on the bottom picture of A5 Palita progeny trial using the SNV calibration for TOC and TN, and the first derivative for pH. So from the result, they show there is a variance in between replicate 8 and replicate 4. And the result also shows that concentrations for both organic carbon and total nitrogen in replicate 4 are lower in the A horizon than the B horizon, presumably due to the runoff from A horizon and slow percolation of nutrients into the lower depth soil where they accumulate. So this study shows the ability of NIR spectroscopy to provide high spatial soil data along with spatial analysis of variance of growth. As for conclusion, the result shows the practical use of a handheld NIR spectrometer to predict total nitrogen, total organic carbon, and soil pH in soils across plantation forest sites in Sabah. And the results for organic carbon are similar to other reported calibrations as we speak before to the neighboring country, and is acceptable for total nitrogen results. While pH was not validated with test set, but the results are comparable to other recent studies. And that's all from me. Thank you and have a good day.
Thank you very much, Mr. Hamzat Fahmi. Ladies and gentlemen, fellow participants, we will be having a tea break time here, Malaysia time. It's 4 p.m. here. So we will come back in 15 minutes time and we will continue with another 7 poster presentations. For your kind info as well, we are trying to get back Dr. Mahiswaran to present his presentation. So we pray that we can have him back again here in the conference. So I will see you again in approximately 15 minutes from now. Thank you very much.